Yeah, we're getting started in a couple of minutes.
See if I can't.
Recording.
Hey, welcome, everybody. This is a presentation by Matthew and myself. I'm going to be providing the first part of it, and Matthew will be providing the demonstration. This is a response to your feedback. This is what you've asked for, and we're going to see how it goes. For those of you who've had me before, I ask that you, if you do have questions, and we're open for questions, use the, you can raise your hand, just speak out, or use the chat. So use the chat for questions because I will be monitoring it. So we sent out the agenda, and just going over, we're going to look at Amazon Web Services. That's really the focus of this, and we want to make sure you're prepared to get there. You've all graduated, so this should be familiar, but so we'll just go over it intuitively at first, and then Matthew is going to dig down as he demonstrates some significant details. We're going to look at the virtual private cloud, public subnet, private subnet, internet gateways, or AWS's equivalent to a router. We'll look at routing tables, how we connect the internet gateway to a subnet, application load balancing, EC2 instance. You'll see what that's about if you're not familiar with that. And then we'll just look at networking, public versus private IPs, layer 4 and 7 of the OSI model, the CIDR, that's the way I pronounce it, CIDR notation. What's that? Take the mystery out of that. Look at the request response cycle, anatomy of a packet, and then cybersecurity. We'll go over SQL injection, and if there's time at the end, we'll look at NIST, complying with NIST. So any questions on our agenda? Okay. Let's begin with the cloud paradigm.
Before we start, would you mind if I just said a disclaimer real quick?
Please do.
Thank you, Richard. First and foremost, folks, Richard and I are so excited to deliver this this lecture to you folks here tonight. I just want to kind of come out of the gate here before we get started and kind of demystify, or, you know, just be completely transparent, because when you folks were students, now that you guys are alumni, kind of on the way to your you've already started your journey on becoming cybersecurity professionals. You already are cybersecurity professionals. You're beginning your career journey as of right now. So for those folks that have graduated, that are alumni before November, Coding Dojo no longer offers a cybersecurity program under the Coding Dojo umbrella. the whole cybersecurity department, including myself and Richard, we no longer are affiliated or associated with Coding Dojo. That does not stop our love of wanting to impart wisdom, talk with you folks, and kind of answer questions and deliver it in the way that we are possible. So what Richard and I did was we actually wanted to give these lectures. That's why you folks received the forms, and we wanted to see if there was enough attention or if there was enough interest. And you guys, I am floored by the response. It is so good to see all you familiar faces right around here, and I really do appreciate you guys taking the time out to spend it here with us. We have this is kind of a pilot to see. The majority of the responses said that you guys wanted to do cloud security and cloud blue teaming and networking. Those were the biggest response. I want to say maybe about 85 to 90%. So Richard and I put together this presentation just like we did in the last cohort that we taught together here. So if you guys are interested, if this is actually helpful to you, we will be sending a form to you out after this, just for some feedback. If you'd like these to continue, we can go ahead and make that happen. But either way, I really appreciate you folks joining us here today and excited to get into this. Thanks, Richard.
Well, thanks, Matthew. I'm going to talk just a bit more about that when we get to the break. But thank you for introducing that. So getting back to the cloud paradigm, let's, for those of you who've had me, let's take a little perspective on this. Why is it so compelling? Okay. Because two profound factors have come together, and that is demand, and I'm going to call this consumer demand, right, and the opportunity for providers. And we'll see these are so powerful. Okay. And so if you're a small or medium-sized business, are you going to create a data center? Probably not. It's too expensive. Even if you're a big business, is that business you really want to be in? Or do you want to focus on your core competencies and let somebody else do it? Okay. I ran a small business. Matthew has run small businesses. Right. You don't have the staff, you don't have the energy, you don't have the direction to do that, even if you're expert in information technology, right? Because it's, how do you run something 24/7, 365? Just think of how much staff you need, how much expertise you need. Right. So there's this demand, right? And what the providers can do now, and we'll see this, is provide what I call a smoothly extensible infrastructure. Okay, and we'll see a little more what that means. All right, it's resilient and expandable. All right, they got multiple data centers, they got backup, they've got redundancy. All right, and as we'll see, you can get a little, you can get a lot, and it's seamless. Okay, and most importantly, and this is what makes it so powerful, it's cost effective. And when we look at AWS, we'll just see how cost effective that is. Okay. And so what it creates is this flexible virtual environment. Okay. When I was growing up with IT, there was nothing like this. It was quite brittle, right? Very difficult to size. It was a constant problem when I was at the computer science department of Westinghouse Research and Development. That was a major challenge. We purchased too much, and soon it would be too little. We were constantly struggling. And so what's come out of this is this idea as a service, right? All these different, whether it's software as a service, a platform of a service, infrastructure as a service, right, and so on, right? And so the other guys are doing the heavy lifting, and you as the end user are getting the utilization. Okay. And so what it does, bottom line, it lets companies now focus on core competencies. Okay. And the kind of the bottom line from the other side, and that's why I talk about opportunity, it is profoundly profitable. Look at this. This is recent. I just looked at this in the last week. I got this from a CNBC. Amazon's a huge company. And in a sense, only 17% of their cost, their operating cost is the cloud, is Amazon Web Services. But look at its profitability. That's what this operating income is. It's 62% of all of Amazon's profits, right? So this isn't going away. We're going to have these services available. Obviously, if it's true for Amazon, it's going to be true for other vendors as well, right? This is critical, this compelling model. So any questions on this? Okay, let's drill down first to Amazon Web Services, and then we're going to look at the networking. Okay, so AWS stands for Amazon Web Services. Okay, that's the cloud. All right. Guess what? It's got over 200 services, and I got this from Amazon. I don't know what they all are, but I'll give you some highlights. Okay, computing, obviously, databases, analytics. And so when you think about as a service, right, these kind of fill into different strata. Okay, networking, mobile, yes, they have mobile services, developer tools. So you see how specific it can get. Internet of Things, security, enterprise applications, and so on and so on. Okay. Now, some of the things that drive the consumer side of this is these are on demand. I don't have to go out and order equipment and wait until it arrives. I just go to Amazon and it's there. Okay. Now, this is what makes it the compelling consumer model. You pay as you go. It's like, how much do I need? Well, whatever I need, that's all I have to pay for. So you can see how powerful that is from the consumer side. And it's global. Global data centers. And not only is it pay as you go in terms of I'm only paying for what I use, but if I decide I don't want to use it anymore, there's none of these termination fees. There's none of these subscriptions that you have to get whether you use them or not. All right. But it's 62% of Amazon's profit. So let's not feel bad for them, doing quite well. So any questions on AWS? And Matthew is going to be demonstrating this. So let's look now at networking. I'm going to give a preview and I'm going to go over some specific items that are going to be demonstrated. Okay. Now, hopefully you've seen this before. This is the OSI model. I'm just going to review to kind of set our stage and set our perspective. Okay. We're going to look at public versus private IPs. This is a preview. I'm going to cover these subsequently. We'll look at layers 4 and 7 of this model. We're going to look at CIDR notation, the request response cycle, and the anatomy of a packet. So any questions on this preview? Okay. All right, let's begin with public versus private IPs. Let's just take a little history. The internet was created in the late 1960s by ARPA, the Advanced Research Project Agency. They were associated with the military, so they kind of renamed it DARPA, which is Defense ARPA. But the original internet was called ARPANET and then DARPANET. And they said that was in the 1960s. Now, when they created this address space, and this is just for reference, this idea of class A, B, and C networks, that's kind of come and gone. Primarily, we deal with class C networks, but I just leave this for your reference. This will be published as a video, so this will be available to you. And they thought, oh, 4 billion nodes, we're never going to run out. All right, so keep that in mind. However, what happened, of course, is they ran out by the late 1980s. All right, and into the early 1990s, saying, you know what? We're going to run out of addresses. Now, one of the things that they built in was private addresses. And when they first built them in, way back when, the idea was, well, everybody will connect directly to everybody else, but you know what? If you want to do testing, we have some private address space for it. And that was the original purpose of private addresses. But then they realized, well, how are we going to, if we want to convert, and they came up with IP version 6, which is there, which is going to have a much larger address space. All right. How do you do that? Because everybody's got to do it at once. Well, that's going to be hard. It reminded me, this was before most of your time, back in the 1970s, US was going to convert to metric, right? And in fact, when you look at your speedometer in a car, right, it's in both the English system and the metric system. They still haven't done that because it's like, how are we going to get everybody to do that all at once? So it was one of the challenges. All right, the same thing we have with IP version 6. It's certainly superior, but how do we get there? So what they did is they kind of converted this idea of private address space through NATing. Okay. I'm sorry, I got ahead of myself originally for testing, but then they said, if we put the private networks separate, all right, and we do network address translation, which you should be familiar with, all right, it actually serves two purposes. The one is it now lets us to continue with these limited address space. 4 billion is limited these days, but it also provides security because now nobody can get directly to my private addresses. So it has a dual purpose. So it's actually done quite well, okay? But these are the three private address spaces. They should be familiar with these. Typically, we use 10.0.0.0 and 192.68.0.0. And you can see this is the range here. But you can use this other one, 172. It's actually the latter half of the next octal quarter. So any questions on public versus private IPs? Okay. All right, now let's look at two specific layers of the OSI model. We'll see why these are so significant. Okay, so again, here is the OSI model. You begin at the application level and you work your way down to the physical, and that's how you communicate across the network to the other physical, and then you would go back up. And you should be familiar with that. But let's look at layer 4 is transport. So what's that about? Okay. And you notice that's at the host level. Now that's important. All right. This is how we get the information from one location to another, but this is how we organize the information at the host layer. And so what it's providing for us is reliable data transfer. Reliable. All right. So it's got to have something built in to ensure that reliability. Okay. It has flow control. All right. And as we'll see, if we're communicating, certain times we're communicating in real time, say the streaming portion of this engagement we have right now through Zoom. All right. That doesn't have flow control, as you know. Okay, when you're watching a video, because it's moving in real time. However, some of the other elements of it, for example, if you enter something in the chat, that will have flow control. So be aware of that. That means, wait a minute, I'm too busy, would you please wait? And it will do that. We can do segmentation. All right, what I'm sending might be too long for a single packet. I can create segments. Okay, also as error control, very important. As we'll see, the TCP protocol, right, is error-free. How does it get error-free? It looks and sees if there's things like parity, and if there's a problem, it'll retransmit. Okay, and it may have states or what we call connections. All right, and that's something, again, you should be familiar with. That is, if I start a session, whoever I'm in a session with is going to remember what I did last, and that's going to be relevant until how what I do next is interpreted. And the examples of that are a TCP, which would be a stateful connection, UDP, which would be a streaming connection. But these are defined at these upper levels. Okay. Now we also have layer 7. That's the application. That's the highest layer on the OSI model. And that's where the human connects with some application on the computer. But that's at the human level. So that's the most intuitive, the most accessible to the individual. So any questions on these layers? Okay, now let's look at CIDR. This is like a mystery for a lot of people. It's not that mysterious. To me, it's kind of, you don't like to type. So, but let's use this. I think it started off as a shorthand, but it does have some meaning and relevance to us. Okay. So it stands for, if you've never heard of, classless interdomain routing. What a name. Okay. This table is full. We typically don't use every prefix, but what it is, it's a shorthand to indicate the address range that we're looking at. And the way it works, if you had an IP address of x.y.z, right, notice there's only 3 of these octal digits, octal expressions. They're octal expressions. Okay. 3 octaves each. And said that was /24. That says that there are 24 bits that are spoken for. And if you do the math, there's 32 bits in an internet address. All right. So it's kind of backwards in a sense. That means the range that's available is 0 to 255. Okay. Now the other way you can look at it is that I like to think it inversely counts network addresses. So if you do the math, the /24 becomes 2 to the 32 minus 24, which is 2 to the 8th, which is 256. Those are the addresses available. If you go on the other side, if you have a /8, so you see there's only 8 bits that are fixed. All the rest are addressable. You can see there's 167 million addresses by doing the math. 32 minus 8 is 2 to the 24th. Okay. All right, so just kind of put this in your back pocket. It does come up. All right. Typically, you just look at a table like this to figure out what's going on. So any questions on CIDR? Okay, now let's look at the request response cycle. And this is the heart of the web, why the web was designed. So let's take a brief history. For those of you who've had me, I've talked about this before. It's worth going over again because it's really paramount to why the web is so significant and why this particular process and this technology is so important. The web was designed by Tim Berners-Lee, who was a scientist, a physicist at CERN, which is the largest particle accelerator in the world. And he was there in the late 1980s, and he recognized that there was a problem. Now, the internet existed at that time. There were communication links, right? And what did CERN do? It smashed subatomic particles into each other and produced a huge amount of data, right? At the time, even at that time, we were talking about terabytes of data. And the purpose of CERN was pure scientific exploration, right? And so they wanted to share this with scientists throughout the world. Well, how are you going to get the data to those scientists? If you, how do you get terabytes? I mean, the internet, today you still couldn't do it. but back then, how would you communicate it? Right? You didn't really have a good way. You had things like Kermit, and FTP and Gopher. Right? These were slow, kind of clunky protocols. Right? So Berners-Lee said, well, if we look at hypertext, right, and we think about the problem, suppose we keep the data locally at CERN in its big servers, and we allow users to connect to CERN and manipulate that data, keep the heavy lifting at CERN, keep most of the data at CERN, and do the presentation and some other commands at the local user. That was a solution. That was the web. That's why you designed it. And of course, like all good solutions, this is so powerful for lots of different things. And we kind of speak about generically as the request response cycle. But that's what's going on. This idea of client server, right? This is the heart. Okay. And so what it does, as you can see, it distributes the workload. Right. So what is my local computer going to do? It's going to do some computation. But it's going to do a lot of presentation. Okay. It's going to kind of parse my commands, right, and send them over. It's going to receive things that'll paint my screen, but it's going to do the work on painting the screen, right? And you see what a beautiful balance Berners-Lee created in this protocol. Okay. Now, some of the other things it does, as I mentioned, it's going to manage network traffic, right? It's kind of just right. It's just the right amount, right? We're going to move what we have to move across the network. We're going to keep most of it on the server and some of it on the client. Okay. At the same time, it's also going to balance processing, right? The heavy lifting processing, probably on the server, but the screen painting kind of processing and some of the query initiation on the client. Okay. Now, another thing that comes up is when you have multiple servers, okay, well, how do you decide if a user is coming in, client's coming in, which server? That's what a load balancer can provide for you. Right? There's different ways of load balancing. You get the idea where it can be simply round robin, server one, server two, and so on. It could be who's least busy. And there's some other things. It could be what exactly are you looking for? This service specializes in that. So any questions? Okay, now let's look at a packet as we work our way through the OSI model. What we do is we want to exchange information, and there's certain data, but then there's certain information about that data, what typically is characterized as metadata. Okay. And so some of the key elements of a packet are the addresses: source address, destination address. Okay. Got ahead of myself. Okay. But also there is a protocol in the terminology, which it comes from the original Internet Protocol. We call it a port. You might think of a port as a sub address. That's the way I like to think of it. There were some notations that actually add another period in the port to the address, but we really are separate fields. And you notice both the source and the destination can have a different port. Now, that would be somewhat odd, but it is possible. Okay. Now, there are some what I call field dependent. And you can just look at them. You'll see things like, is it fragmented? Are there flags? Is there a checksum? Very important. These checksums are critical. They ensure the integrity of the transmission. Things like time to live. Yes. All right. This packet can only live for so long. All right. So if it's taking too long to traverse the network, sorry, you're gonna have to retransmit it, okay? And I see length is misspelled in this, but you get the idea. So it's a variable length field. That's pretty cool. Okay, so you have that length, flags, and some other controls. So any questions on the packet? Okay, we're going to finish up. We'll talk about SQL injection. Okay. So SQL is, of course, stands for a structured query language. Right. And again, you should have been exposed to this. It can get complicated. On the other hand, it's kind of, there's some basic elements of it. Relational databases, if you're not familiar with it, you could spend a little time just looking intuitively at what that is. The important thing for us is that information is accessed through queries. Right. And so let's see, kind of deconstruct a query. And this term I've introduced. You get an intuitive sense. There's a verb. I'm going to select. All right. That's an action I'm going to take. And there's a qualified. It could be from somewhere or where something. It just depends on what I'm trying to accomplish. And then there is what's called conjunctive operators. Could be an and, which is a conjunction, or it actually is a disjunction, but that's the generic term for them. All right. So one of the ways of implementing this client-server model, even something as simple as a logon, is I look for that user in a database. And so what I do to access the database is a query. And when something is implemented like that, it's really cool to implement it. It's quite elegant. It also involves a certain risk that if you're not careful in the implementation, somebody can trick you, right? And because you have this powerful structure of queries, I can introduce into that query this term which says or 1 equals 1, and you think, why would somebody do that? Well, if you get into the details of queries, this 1 always equals 1. So 1 equals 1 is always true. Or is a disjunction, which means if something, if A, whether A or B is, whether A is true or not, doesn't matter if the second part of the disjunction, 1 equals 1 is true. It's always true. And so what it can do is wind up presenting every account, for example. Okay, so just keep that in mind. Okay, web implementations may use SQL because it's powerful, it's easy to program, it's kind of neat, it's kind of fun to do, right? And it does, as I mentioned, create a risk. And that is that we return all possible matches. Okay. So any questions? Okay. Okay, before I break, I want to just follow up on what Matthew had discussed. Matthew and I are working on a project, Hack Armory Academy, where through understanding what students like you are looking for, we will be in the future proposing opportunities for you to learn more. Okay, in a formal situation. All right. What we're doing now is soliciting from you your feedback. Right. What will be relevant? What we want to do, kind of to follow on what Matthew had initially spoken to, is provide a responsive service. Right. That is focused on your needs, your goals, your ambitions, and provide a service that helps you get there. But we're in the very early stages of that, okay? in addition, I am also going to be publishing intuitive kinds of presentations. For those of you who have taken classes with me, should be familiar with them. Right? Giving a perspective, giving context. And I've set up a YouTube channel for that. For example, the portions of this presentation will be posted on that as well. But it is for intuitive ways of learning cybersecurity based on what folks like you are looking for. So I'm going to break here. So Matthew, we'll take I guess we'll take a short break, Matthew, and then you can.
That sounds great. Yeah, let's go ahead and break for about maybe what 3 minutes. Let's get back here at 5:37, and then we'll get on with the hands-on presentation here. And I just actually want to go ahead and piggyback off what Richard was saying. Yeah, so we are actually in the midst of getting this project going. However, I want to stress and I want to reiterate that we are not trying to sell you anything. We are not after anything about that. What we are wanting to do is something that's mutually beneficial. If you guys like our teaching style, we want to cater to you. We just want your feedback, and that's pretty much it. And if this is actually of service to you, we'll go ahead and keep that along. But just make no mistake about it. We're not gonna sell your email. We're not gonna try to pitch you anything. This is literally what you see
That's
is what
right.
you get. So I want to clarify that.
Yeah, I don't like that stuff. Yeah, when I ran my clinic, I didn't ever do any of that kind of thing. No, because if I don't like it, why would I subject somebody else to it?
Absolutely.
If we're presenting something complimentary, that's what it is. All right. And if we, in the future, if we get it together and have something, you will know up front, right? You know, what it costs. Yeah, I don't want to get, you know that when you go through this and then at the end, it's an ad, you know. If it's an ad, we'll tell you up front.
Absolutely. I don't foresee that. So yeah, just wanted to go ahead and clarify. We really do appreciate seeing you here. This is nostalgic for me just because seeing all your names on here, it's been a good time. So at the risk of sounding like a broken record, thank you again, folks, for joining. And not saying that we're wrapping this up. We are going to do a demonstration. I'm going to show you folks how to build up a networking on Amazon Web Services, and we are going to be configuring a load balancer, some servers, and setting up some firewalls and demonstrating how we are going to be defending against some attacks here. So
yeah, that's the meat of it. I just gave an intro. All right. Well, we got a good turnout.
Bukola, would you mind? I'm not sure I understand. Do you mean follow along at home with what we're about to demonstrate?
The question is it possible after you've demonstrated, is there a way where we also get to do hands-on by ourselves? You know, the way we normally you demonstrate something, maybe we have a VM and we can do practice. So is there a way, any way where we can set up a similar environment or something? I don't know. I'm just asking.
Oh, Bukola, that is an excellent question. So that is one of our goals here, especially Hack Armory, or putting together this for you folks. I wanted to give you with previous lessons. I'm going to do my best to separate us from the how we were all kind of introduced and brought together. But there was one thing that I did not like, that there was not a lot of production environment, things that we can actually replicate and that actually got us prepared for the real world scenario. A good foundation is definitely key. However, when we augment up, we want to give you exposure to that. So for this, all intents and purposes, my demonstration, as long as you have an AWS account, you will be able to replicate this. But there is just one little caveat. AWS has a lot of free tiers, so stuff that will not charge anything whatsoever. However, some of the things that I will be doing today does come with a charge, especially with the firewall. The prices are pretty much set. However, it's not going to be much, but if you actually want to go ahead and demonstrate, as long as you tear down everything after you set it up and test, it's going to be minimal charge. I think my AWS account right now is at about 33 cents for the month. So it's very minimal, but I just want to throw that out there too.
Thank you, Matthew.
100%. Great question. All right, folks, looks like we have been about 3 minutes. Let's go ahead and get this show on the road. Mr. Richard, if you could grant me host permissions, I cannot share my screen just right now. Or co-host, something like that. All righty, folks. Yeah, well, we're waiting for the for me to get privileges for the screen share. I just want to let you guys know just somewhat about me. I was really pleased to see all the responses that we got that pertained to cloud, because after we were parted from Coding Dojo Perdoceo, my job now is I'm a SecDev Ops engineer, a senior SecDev Ops engineer for AWS security. I have certifications in AWS cloud and all that other good stuff, and that is pretty much my job. That is what I've actually moved on to. So if any of you folks have any questions about cloud security or SecDevOps or anything like that, because security, operations, development, they all kind of mesh into one, I'd be happy to answer those. You folks have my email from the mailers that Richard's been sending out right here. So folks, thank you so much for that, Richard. Let's go ahead and share this screen. Man, it's been so long since I've done this right here. Can you guys see the little diagram that we have up here? Yes, awesome. Thank you, Wesley. Thanks, Jesus, Wadina. Appreciate you guys. All right, so this in a nutshell, forgive my diagramming skills. This is what we're going to be building out today. So as Richard went over, we need a VPC. A VPC is literally just a network architecture that is on somebody else's computer. That's all that it is. We can actually we're pretty much putting our stamp on this. We're creating a fence so we can actually build resources in there. So we can't build just resources anywhere. We have to have a subnet. A subnet, if you guys remember from our virtual boxes, of course, everything else. A subnet is just basically a plot of addresses where we can just plot things down. So let's say if we have our private addresses for this subnet, it's 10.0.0.0/20 or 16. That means that 10.0 and the network identification can be anywhere in those last two octets. So if I put that this is 10.0.0.0, let's go ahead and annotate this. So let's say this subnet is 10.0.0.0/16. This means right here that since 16, that means this and this is off limits. That's going to stay no matter what. But anything that we create inside of here is going to be assigned an IP number, and this could be a variable of that, anywhere from 1 to 254 and 1 to 254. All right, so let's say we create a load balancer. That IP address could be 10.0.4.50. And then same with these EC2 servers, which is going to be our computer, and we'll get into that a little bit later. So what a VPC does, it basically says, hey, all right, this is going to be my network identification. This is going to be my host identification. How many different ports do we want open for what we are going to be putting, these resources that we are going to be putting in our network to ultimately get our own website started here? And what AWS does too, and actually there was a good point made in the chat that this is not centric to AWS. Google has GCP. Spotify actually just moved from the music streaming service. They just moved from AWS to GCP for latency issues. So everything that we're talking about right here is offered through different cloud providers. They just go by different names. We're using AWS here just because that's pretty much what I'm the most familiar with. And it's I don't know the metrics, don't quote me on this, but it is they have been front runners since they've been around since 2006. So it's been around for about 18 years. So in AWS, as Richard says, they have warehouses that are all over the United States and all over the globe. What this means is there is different availability zones. So in my VPC, I can have a subnet that is located in California. I can have another subnet that is located in Oregon. And what does that do? Remember the CIA triad. Go ahead and unmute yourself, throw it in the chat. If I have servers in different area codes, in different availability zones, what does that do for me, for my finished product that I hope to get out to consumers? What does that help me accomplish within the CIA triad? Courtney says redundancy, 100%. Dante says redundancy, and Wesley says availability. You guys have not missed a step. That's exactly. I want 99.9% uptime. I'm trying to sell some stuff. I'm trying to schlep. Let me go ahead and pick on somebody right now. Let's say Courtney. Let's say that you were opening up a shop and you were building a website on AWS. What kind of shop would that be? What would you be bringing to the people here?
Shop? I don't know.
It could just be anything that you like, any hobby that you might have, something like that.
Selling insects like ice pods, springtails.
That's a good. I wasn't expecting that one. That is
It's
a good
really
one.
it's random, I know.
No, the random the better. That's awesome. And I'm actually really happy that it interests you. That's pretty cool. Okay.
Yeah, I have a bunch of geckos, so it kind of works for that.
Oh, sweet. Not to get off track here, but how many geckos do you have?
I have 5 geckos and I have 7 or 8 snakes. I can't remember.
Totally cool.
Yep.
Oh, that's awesome. So yeah, so Courtney is she's going to be starting up her own insect shop, and she wants high availability. Richard over here, he is starting up his own insect shop out of Florida. He just goes into his backyard, he can collect them all, and he wants to find a way to monetize this. He does not want he's in direct competition with Courtney, so he's going to try to do something shady with his cybersecurity. So he's going to go ahead and throw a DDoS attack over at Courtney. So since Courtney has her servers set up in different availability zones, let's say that Richard takes out one of her servers. We have what's called a load balancer. A load balancer is going to not only scale, so let's say that there's a bunch of traffic coming, they will scale out the resources in the same availability zones, but it will also say, okay, this one's down, we're going to route all the traffic to the server inside of this other availability zone. So it gives us redundancy and it gives us availability from the CIA triad. So you guys hit it right out of the park. Before we jump over to AWS to start building this thing, does anybody have any questions on anything that I just covered right here? That versus Skype 3.0, nice. Awesome. All right, let's go ahead and get over. So we are in, this is the AWS Management Console. So what we're going to be doing today is something that's called app clicking. So we are going to be doing this through the console home. There are other metrics. Just for a full transparency, I'm going to try to give you the comprehensive things of how we actually do it in the field versus just kind of getting our feet wet so we understand the principles here. So there's also something called infrastructure as code. We can provision different assets or resources as we have right here by writing lines of code. That usually is faster. If you folks are interested in actually learning that, please go ahead and respond back with that on the feedback form that we gave you, and we can absolutely do a follow-up lecture on that, but I digress. So with this being here, there's a recently visited, I see my current month cost is 12 cents, 47 cents. So full disclaimer, if you are following along at home, some of these are not going to be free. However, if you delete them after you test them, the cost is going to be very, very minimal here. So first thing we want to do is we want to create a virtual private cloud. So I'm going to search VPC over here, and we're going to click on just that. All right, so we have VPCs. So you're going to see that we already have some VPCs. We already have some subnets. That is default for Amazon. Amazon wants to pretty much get you up and running right out of the box. So these come default whenever you open up an AWS account. I don't want to do any of this stuff. I want to build this up from scratch because I'm a control freak. So what I'm going to do is I'm going to click on your VPCs, and you can see that everything has a name, everything has an ID, and everything has what's called an ARN, Amazon Reference Number. We will be getting into that just soon, but one thing that we are going to be looking at is the names, and keep in mind the IDs, because every single component needs to reference an ID. So think of what in your home network, how do you connect your router to your computer? You have a cable, you got Wi-Fi. The Wi-Fi references the ID of your computer, the MAC address, et cetera, et cetera. That's how we create handshakes. That's how we get everything connected. The VPC ID and the resource numbers is how Amazon's cloud references these different moving parts to kind of connect them together inside these subnets. So that's what's going to be important. But without further ado, we're going to create a VPC, and we're just going to do a VPC only. There are VPC and more. It'll automatically create subnets over different availability zones. See US West 1B, 1B, route tables, network connections. But we're going to build everything up from scratch here. That's just a kind of quick start if you're in a hurry here. So my name tag is going to be, let's see, Matt's Amazing VPC. We are going to be doing IPv4 CIDR manual input, meaning I am going to physically say, hey, this is the CIDR range for my VPC. So I'm going to say 10.0.0.0. That's since those are one of the privates. I could also do the 192.168. I could also do the 172. I'm just going to go with 10. And I'm going to do a CIDR block of 16. So CIDR block of 16 means that we have 32 octets. So we have 1, 2, 3, 4, just as Richard taught us. 16 means 8, 16. These guys are off limits. It also means that these two guys can play ball. We have 1 to 254 in each of these, that all of our resources that we are going to create can go ahead and occupy on this network. Abdur asked in the chat, what are you creating again? We are currently creating our cloud. So we're just basically creating our rectangle of where we can put all of our good stuff in. It's essentially our playground right now. We're just getting the basic setup. Cool. So we can do an IPv6 CIDR block. Not going to go ahead and deal with IPv6. We have IPv4. IPv6, yeah, we are running out of IP addresses. IPv6 is, I would not say, in my professional opinion, on the horizon anytime soon, because it's not going to be a full court press rollout. It's going to be gradual, and we are far away from that. Even though we are running out of IP addresses, we still have enough for the foreseeable future, especially with IoT and all that other good stuff. Tenancy here, you always want to keep default. What tenancy basically means is, hey, all right, Matt, we'll give you a VPC on one of our computers somewhere in Northern California, since that's my US West 1. I'm in the Bay Area, California. That's where I want to create this. Default says, all right, I don't even know where in Northern California you are, but we'll put your VPC there. You click dedicated, they are going to provision you your own special hardware, and that is very, very, very expensive. So do not click dedicated unless you really want to spend a lot of money. Tags. Tags basically means, hey, we have a VPC, and this is how we're going to refer to it in layman's terms. So if we have the name here, the names and the tags are pretty much the same thing. They're synonymous. Okay, what the heck is this that I provisioned? Oh, the name tag says it's my amazing VPC. It must be a virtual private cloud. So definitely it's a good idea to have tags on everything just so you can identify your infrastructure. And then we can go ahead and create that. And we're pretty much off to the races here. So our VPC has been created. All this other good stuff, DNS resolution. If we had a .com name, we could just go ahead and hook it up to here. Does anybody have any questions before on the VPC creation or any of these fields before we move on? Cool. All right. So Courtney is going to go ahead and get her server set up for the insect selling website here. So we can go over to what's called EC2 or Elastic Cloud Computing. It's ECC, but they did EC2 to be kind of edgy. These are what's going to be our servers. So what is an EC2 instance? An instance is a machine that we are pretty much renting out from Amazon. And it's basically another computer that's over in Amazon's server farm. So I'm going to just go ahead and duplicate this tab because we're going to be coming back to this. Up here at the top, I'm going to say, hey, once it loads, it's going to say, we're going to say EC2 for Elastic Cloud Computing. And we are going to set up these machines that we're going to pretty much spin up our servers. Now, this is going to be a bare bones basic server because I just want kind of a simple web page going out. But you can, if you had a big old development project, this is exactly where you would be launching these. So I have 0 instances running. So I'm going to go ahead and say launch instance. So this is where the magic is going to happen right here for creating this. So what's the name? I'm going to say, let's see, Matt's web server. Let's just go ahead and put a 1 on this too. Maps web server 1. Renee says in the chat, the power of AWS, didn't know we could do so much. How much does it cost? That is a thing. So right here, Renee, there is a free tier, and we will be going over this soon. Until you use up, I think it's about maybe 10 gigabytes of bandwidth, then it starts charging you. However, if you're doing this for testing purposes, it's not that much, but just be mindful because I've had AWS bills kind of sneak up out of me because I forgot to delete things. So there is, remember what we did from all of our virtual machines. We have AWS Linux. It's their own specific brand of Linux. We have Ubuntu. We know all about Ubuntu. We can do a Windows server. So I'm just going to click on this. We're going to say Amazon Linux 2, AMI, which means Amazon Machine Image. This is what we're doing, and it is free tier eligible. Hey, that sounds great to me. We can do just like with our own the things with that we couldn't have the different ARM set. We can do actually ARM architecture. We don't want to do that. We want to keep it with x86 right here. I'm a big hater of ARM architecture, but that's a different rant for a different day here. So T2 Micro, this is going to be our processing power. Let me see if I can make this a little bit bigger so you folks can see this. So this is our Instant Titan. So this is free because we're not getting much here. We're getting 1 gigabyte of RAM. We're getting 1 CPU, and it's on something called T2 Micro. If you come over here, we have small, we have nano, we have all this other good stuff. C6i extra large, we can have 32 CPUs, 64 gigs of memory, so you have options. The free ones are the ones that are going to be slower than molasses, but for our testing purposes, this works out just fine for us. So that's what it's going to be. So a key pair login. I'm not going to go in too deep on what this means. A key pair is going to be in either a PPK or a .pem file. So Richard, this could be a lecture that we tackle in the future too. So this is basically cryptography. This is the way that our computer inside Amazon's web farm knows that it's us via a cryptographical hash. So what it's going to be doing is I download something called a .pem file, which is going to have my private key in there. And then when I try to connect or SSH into my computer that's in the cloud, it's going to know that it's me and it's going to give me the green light. It's Richard, Courtney, Jackson. If you guys tried to go ahead and do that without my .pem key that I would actually download onto my file system, then it's going to say, hey, none shall pass. You're not really Matthew. So key pair, I'm just going to say Matthew Richard. I did this today early when I was testing this thing out. So we're just going to say, hey, Matthew Richard. It downloaded a. Let's see if it still has it in my download. Yeah. So here is basically my PEM file right here. And yeah, so if you did not have this physically, if I opened it up, and yeah, so you would not be allowed to connect via SSH onto here. Now what we have is our network setting. So the first thing I notice is our VPC does not say Matt's awesome VPC. So this is on the default. So what I'm going to do is I'm going to click on edit here. Okay. So we see Matt's amazing VPC. I want it there. The subnet. Uh-oh, I do not have a subnet on my VPC. Remember, the VPC is just the perimeter. We need subnets in order to place our resources in. So what we're going to do here is I'm going to come back over to this VPC console, and we're going to create a subnet. All right, so I clicked on subnets over here, and we're going to click on create subnet. We have to attach this subnet. Hey, where does it belong to? It belongs to Matt's amazing VPC. Cool. The subnet name, let's say Matt's public. I can type subnet 1. Availability zone. So here's where we want to set up our redundancy. So in US West, there is 1A and there is 1B, both in Northern California. Perfect. So I'm going to set up Matt's public subnet 1 in West 1A, and we are going to do our CIDR block. So 10.0.0.0/16, that's of our VPC. I want to narrow this down a little bit more. So I'm going to say every single resource that fits inside of the subnet is going to have an IP address of 10.0.2.1. I want 10.0.2.1 to be the network ID. And I can do /0/24. AWS calculates, okay, Matt, cool. 10.0.2.1, we're not going to touch that. That's going to be part of the VPC. But 1 to 254, I can stop screwing this up, is going to be whatever the resource is going to live right there. The tag is going to say Matt's public subnet 1, and we're going to go ahead and create this. And it must be valid because I have a period right here. So go ahead and create this guy. Cool. We have Matt's public subnet. Here is the subnet ID, and we can see that it belongs to Matt's amazing VPC right here. Since we want to actually have, let's go back over to our chart. We want to have 2 subnets in different availability zones so we can spread our servers out. So I'm going to create another subnet right here. So we're going to say Matt's amazing VPC. Let's say Matt's public subnet 2. Our availability zone is going to be 1B, so different availability zone. And just for the sake of purposes, I'm going to say 10.0.2.0/24. So that means anything inside this subnet is going to be prefixed with 10.0.2. And then this last octet is going to be randomly assigned an IP address for where this resource is going to live. And these subnets are created. So sometimes I have a lot of students, and even myself, I'm like, okay, let's refresh. This refresh, it's only showing 1 because there's a filter. You want to clear these filters, and then you're going to see everything. So we have Matt's public subnet 1 and Matt's public subnet 2. Now we actually have the real estate where we can actually put these servers in here. So let's go ahead and go back over to the server here. So subnet, I'm going to press this refresh. And look at this, Matt's public subnet 1 and 2 is all good. So Matt's public subnet 1, we want to, so here's my caveat. Traditionally, you would actually want your servers to be in a private subnet, and you would want your load balancers to be in a public subnet. The reason is because we would want all of our traffic to hit the load balancer, and then the load balancer, and only the load balancer, that would have access to our servers inside this private subnet. We would not want our subnet to have internet access because I don't know what this machine, this AMI is. I don't know if all the ports are secluded off. I don't know if somebody put a backdoor on here at Amazon because they were so mad. Generally, you only want the load balancer to have access to your EC2 instances. However, for simplicity's sake, we're just going to be doing these in public subnets for these servers. However, in production, these would be in private subnets, and the only thing that you would associate with would be the load balancer. So the load balancer would be able to connect to it, and that's it. Anyway, I did not mean to digress. So I'm going to say that we do have a public IP because without a public IP, I could not SSH into this computer to get our websites up and running. So I'm going to say assign the public IP. If this was production, we would not be doing this. So right now we have security group. So this is a firewall. This is not what we're going to be looking at. This is not AWS WAF. However, this is a firewall or a security group at the layer 4, at the network level. So we're going to be doing a AWS WAF at the application level, which gives us a lot more modular control. But this is on layer 4 here. So I'm going to say create a security group. So we're just going to say Matt's security group. All right, and the description is going to be access to SSH and HTTP. I believe it was Renee. Was it you, Renee? I apologize. In the chat, when Richard was going over request and response cycle, he says, oh, is this having to do with public and private keys? If we were going having traffic on port 443, that is if we had a security SSL or TLS certificate from a certificate authority that would encrypt this. We could absolutely do this with here, but for the sake of brevity and time, we are going to just be going on regular old HTTP. So bonus question for y'all. Unmute yourself. Throw it in the chat. What is the, let's say if we are going to be hosting this on port 80, HTTP protocol. What does that mean for us? What kind of vulnerabilities does that open this up to our product here, our server that we're creating? Kimberly, gold star, absolutely. Jackson, gold star. And Courtney, gold star. You guys hit this out of the park. Exactly. It is unencrypted. So that means all my data in transit is going to be, Richard could just set up a man-in-the-middle attack, monitor all my stuff, and get everything in plain text, just like Jackson said. It is not secure. So only do this for testing purposes. If we did have the certificate authority, and it's It doesn't cost much. It costs about maybe $5 to $10 if you do it through AWS. But that way it is encrypted, and if somebody did do a man-in-the-middle attack, who cares? They couldn't read anything because they couldn't decrypt it. So I want to say I'm going to allow SSH traffic, and I'm just going to say from anywhere. This is not good. If I was in production, I would say, okay, I only want to do this from my IP. However, as of right now, we are doing anywhere. With this 0.0.0.0/0 means from the internet right here. I also want anybody on the internet to be to get HTTP. So HTTP port 80. So anywhere on the in the internet. So that means port 22 is open and port 80 is open right now. That's what we want for that security group. So we are good to go. And after that, what we're going to do is we're just going to go ahead and launch our instance. So right now, what AWS is doing is provisioning my computer, and it looks like it is successful. So if we come back over here into this EC2 instance right here, it's going to go ahead and load. It takes a little bit to provision, so we're going to have pending here. Usually takes about maybe 1 to 2 minutes here. Abdur says, can we add TLS here? We absolutely could add TLS, Abdur. That's a great question. However, we would need a certificate to do that. So you can go to your Googles, you can even do Amazon. Amazon has a service in here, one of the microservices that they do have to actually generate a certificate for you. However, we're not going to be doing that today. If you'd like to see it in a future video from myself and Richard, please leave it on the feedback and we can definitely do that as well. Cool. All right, folks. We have our VPC, we have our subnets, and now we have our server. We have one of our servers right here. Let's go ahead and connect to it. I want to build my website. I'm kind of itching to get over here. So I'm going to click on this, and we're going to click on connect. Okay. So, instance is not in a public subnet, associated subnets, et cetera, et cetera. Okay, I don't care. Shut up, AWS. I want to connect. So what it's going to do is it's going to connect to our instance via our web page. So this is just like having a VirtualBox right on a web page. We're going to get the terminal right here. And this is going to fail. So this is going to fail because it's unable to connect to your instance, probably because when I was being very, very impatient saying, hey, Matt, bro, your subnet's not public. I'm like, wait a minute, it is public. I said, Matt's public subnet. No, that just because we named it public doesn't make it public. So we need 2 things to do this. We need an internet gateway. So an internet gateway is basically like a router. How we are all connected to the internet right here is through our routers. So we have everything here chilling. It just has no link. It has no ISP, no internet service to get out to the actual internet. So let's go ahead and create that. I'm going to create our internet gateway. I'm going to say Matt's, we're going to say IGW for brevity. It's going to tag it as that. And that's it. We now have a router. So now that we have a router, we need to say, okay, a router exists, but where does it belong? Like, you know, cool, Matt, you have a router, but there's no cord that's connecting it to anything else. So I'm going to click on actions here. I'm going to say attach to VPC. What's my available at VPCs? Oh, hey, my amazing VPC. It's going to get the ID right here, even though we have this is what the reason for tags are, because I wouldn't know this ID from anything else. And we're going to go ahead and attach it. It is attached right now. So now our VPC has internet connectivity. Okay, our VPC has internet connectivity. So here is our internet gateway. So we have internet connectivity, but our subnets do not. Our VPC does, but our subnets do not. So now we need something called a route table. We need to associate our subnets with a routing table and say, hey, routing table. All right, we got the ID of this internet gateway. We got the ID of these subnets. Let's go ahead and match them together. It's like matchmaker over here. Routing table is just building associations between 2 different things. Okay, so we have route tables right here, and this is going to be very, very fun and very, very easy. So we're going to create the route table. We're going to say Matt's great route column table. We need to say, okay, this VPC belongs to my amazing VPC, and the tags are Matt's great route table. Okay. All right, we are done. We have our routing towards here, but wait a minute. I want the actual internet. Okay, we have access to the ISP, but we don't have any rules that say, hey, the internet needs to be able to access this to pretty much let us get out of the VPC and inside. We have all the tools. We have not told it explicitly that's what we want. So what we're going to do here is we're going to say edit routes. All right, so we have it. This basically says every single thing inside of our VPC, our different subnets. As long as it's inside of our VPC, hey, go ahead and talk to one another. Subnets, talk to one another. I don't care. But we need to add this to the general internet right over here. So we're going to say 0.0.0, and this is going to be, we're going to attach this to our internet gateway, okay? And this is going to be Matt's internet gateway, what we just provisioned right here. So that's where it is, subnet. And we're going to save these changes. And now we are pretty much all set. We have everything set in place, so we can go ahead and configure the our EC2 instance right now. I'm gonna pause here. Does anybody have any questions, comments, or concerns before we actually set up some basic dummy web page right here? Abdur says, who is providing that internet? AWS or your ISP? AWS is going to be providing it. Since they are already providing this website to us, it's basically saying, okay, hey, who are going to be providing it to? The entire internet? Cool. So they opened up the drawbridge, and now we have full access to that. The internet has full access to that. You folks here could actually connect to this, and it would not stifle you at all. All right, so we have that that message that pretty much went away saying, okay, it's saying associated subnet is not a public subnet. Let's go ahead and check out what the problem is here. So Matt's public subnets. So we're gonna check out our routing tables. I believe I missed a step here. I got a little bit too ahead of myself. All right, let's go ahead and oops. This map's made some you can see us look over the routing tables, and we are come over here. Okay. I see. So yeah, I didn't give we gave the access to the internet, but I didn't give it any subnet associations. I did not say, hey, Matt's public subnet is going to be part of this routing table. So do not forget to do that. So what I'm going to do here is we're going to edit subnet associations, and I'm going to put Matt's public subnet 1 and 2 inside of here. Now that we have subnet associations, we are good to go. And look at this. The CIDR is going to be on to here. And if we look back over into our EC2 instance, let's go ahead and refresh this. Renee says, for your information, lots of this information was on the Network Plus exam. This helps those that have not taken the exam. Great point out, Renee. Absolutely. So we have Matt's web server. Let's go ahead and connect to this guy. So if you guys, folks, remember from Ubuntu, from Kali Linux, from whatnot, the way that you actually download files is you use a package manager, which was sudo apt-get for Ubuntu and for Kali Linux. Amazon Linux is based off of what's called Debian. However, they want to use their own package manager. So what I'm going to do is, this is a public IP address. You could literally get this is on the internet right now. You could type this into your web browser, and it would take you to my specific computer. However, we need something called a server. So let's say when Renee actually types in this public IPv4 address, the server says, okay, hey, we have a request. We are going to provide a response. And I'm going to use, there's a lot of you can use. You can use Apache. You could use, whatever, just even HTTPD, the daemon on there. I'm going to be using Nginx. So I'm just going to do sudo su just because I'm going to be running a lot of commands. Just want to do it as administrator right here. So instead of sudo apt-get, they use Amazon-Linux-extras. And I want to install Nginx. So Nginx is going to be the server that we are going to be using. It is going to go ahead and install right over here. Now what we need to do is we need to make a specific web page for this. We need to make a pretty little web page that's going to pretty much say what the deal is. So I'm going to say I'm doing echo command. An echo command basically says, hey, echo, you guys remember this from your build exam. It's going to just basically reprint that out. if we want to actually say from the command line, we want to actually put something into a file somewhere. So Nginx says, okay, what do I respond back to a request with? Okay, I have a folder of a web page. I'll deliver that. So I'm going to say echo, and we're just going to do some HTML. I'm going to put a little bit of a header here saying, this is Matt's awesome web page. And we're going to say 1. And we're going to close out this header. We're going to close out this. We're going to do a redirect, or the big alligator mouth. That basically means, hey, go ahead and put this into a specific location onto here. And that specific location is going to be user, share, Nginx, HTML. I'm going to save it to something called index.html, which is basically a root directory right here. What's going on here? Uh-oh, it's not like it's something. All right, it's not like in my. Oh, I have it too many quotes. So it was saying, hey, this H1, what's the rest of the stuff that was after this, right? So it didn't like that with the word. Yep, we are good to go. Now all we have to do is tell our system, let's go ahead and enable that Nginx server. And then we're going to say, okay, it's enabled. We're going to go ahead and start that Nginx server. And that is those 3 commands, 4 commands, is all we need to do to get a web page running. So if we come back over here, I get my IP address. I'm going to take out that HTTPS. This is Matt's awesome web page 1. Whoop, there it is. We have my awesome web page 1, and it is free right for the taking right here. All right. We need to have redundancy for our application load balancers inside of our different availability zones. So what I'm going to do is I'm going to do exactly what I did right here, but I'm going to do it in that different availability zone. So what I'm going to do here is come back over here to instances, make sure that I pick the other subnet because I forget which one I associated with which. If you folks have any questions while I look at this, please feel free to unmute yourself, throw it in the chats, all that good stuff. All right, so we see here it's on Matt's public subnet 1. So I'm going to throw this new one on the second subnet. And let's get out of here. Cool. Let's go ahead and say Matt's public server 2. We're going to be doing the same exact thing. And the cool thing about this is I'm kind of walking you folks through step by step. If I really wanted to, I could just do a script that would actually do everything that I said, that would actually got the web server up and running. We could do that automatically. That would be more infrastructure as code. So I hate to sound like a broken record or a commercial for us. If you want to see that, let us know and we can make that happen, Captains. We're going to do Amazon Linux 2. We are going to do the T2 micro because I am cheap. And we're going to say, okay, the key pair name. Uh-oh. Yikes. Come back over here. So the key pair name, we have Matthew and Richard, the PEM file that I had earlier today. We already created a security group, so I'm going to use that existing security group. And we actually know, we do not want default. Default, I believe I did not. Oh, so that is something, if you guys are doing this following along later, the reason why we have default and not the one that I created earlier is because I am not on my virtual private cloud. It can happen to anybody. So I'm going to say Matt's amazing VPC. All right, we are on Matt's public subnet 2, our other one. We want to enable this just because we want to configure it. And we are going to select the existing security group that gives us access to port 22 and access to port 80. So I'm going to say Matt's security group. That seems cool by me. So I'm going to go ahead and I'm going to launch this instance. Now we have 2 of our servers running in 2 different subnets. Our vision is starting to come to life. Subnet 2, here's our EC2 server. Subnet 1, here is our EC2 servers in different availability zones. Awesome, awesome. So now that that is being created, we come over here to our instance zones. Abdur says in the chat, can you tell us more about Nginx? That's kind of really more of a developer, maybe even operations kind of questions. Nginx Apache 2, it really is basically a program that just basically goes into the request and response cycle. If you go and request a website from somewhere, Nginx is the logic that I'll actually go ahead and deliver it to you. Yeah, not really much to say there. For the intensive purpose on here, that'll definitely get us covered. Renee says, we have full monitoring on people accessing our servers. How do we sign ports they can access? Great question. So Renee, that would be in our security groups, the one that I gave, port 22 and port 80. For anything production, you would actually give nothing. This would be, you would want to give yourself access so you could access the server, but we were going to be pretty much giving it access by proxy. And you'll be seeing that when we create the load balancer coming up right here. So Matt's public server is up and running. So let's go ahead and connect to this bad boy here. So I'm going to just select it. I'm going to say connect, just like we did before. And connect, and that's going to bring this up. And we're going to get our terminal right here. And Renee, we'll also be, when we do the web application firewall, there's going to be logs in there. I'm going to go through something also called CloudWatch. So every single thing is very, very well documented. If you're blue team or doing a SOC analyst or anything like that, looking at these logs and setting them up is going to be very, very beneficial to you. I'm just going to go ahead and type this out real quick. And we're gonna, so I didn't do sudo su, I wasn't as admin, so now I am as of admin. I'm gonna press the up arrow twice to get that command back. Oh, or try to, maybe not. Next one. Awesome. So the server is all set up. So let's go ahead and make our web page. I'm going to say next H1. This is Matt's awesome web page 2. So generally these would be mirrors of one another. I'm saying 1 and 2 just so you folks can see how the application load balancer goes ahead and distributes these evenly right here. So we're going to say user share nginx /html. Cool. Let's go ahead and enable this guy. Rock on. So now that this is our public IP address for this one, let's go ahead and check this out to see if Matt's awesome web page 2, and whoop, there it is. We have 2 different servers running our awesome web pages as of right here. So now let's go ahead and switch gears. Let's go ahead and say, all right, we have our servers. Now, how in the heck are people going to do it? I'm not going to be like, hey, hey, Abdur, go to 24.46.134. That's not going to work out. And plus, how would I even get, you know, let's say this server goes down. How would I actually get it routed over to here? So we're going to create our load balancer now. So the load balancer has 2 things that we need to configure, okay? And that is going to be our targets, and that's going to be the load balancer itself. And I will show you exactly what this means. So I'm going to click on target groups right here. So a target group basically means, hey, we have a request that is coming in here. Where is the target? Where is the end game? The end game is going to be our instance that we have. Okay, so I'm going to create a target group. So AWS lets you, all right, it's going to be IP addresses, what's called a Lambda function, which we don't have to get into that. Application load balancer. No, we want this to, the end goal is to be one of our instances, our servers that we already have going up. Target group name, we'll just say Matt's target group. That'll allow it underscores for some reason. And we're going to say the protocol. This is going to be HTTP. If you want to do HTTPS, anything else, you have the option. We're doing port HTTP. We're doing this on IPv4 and our VPC. We're going to switch it over to Matt's amazing VPC. Protocol version, HTTP 1, 2, and gRPC. Details of this is not really that important. HTTP 1 will do just fine for us. Health checks. Let's say one of our servers gets screwed up. What is going to be happening is like the load balancer is going to say, hey, if one is not working, we want to make sure that all of our traffic is going to be healthy ones. So the application load balancer will perform health checks. And that's the / right here basically means the root directory. So, hey, check out the root directory on port 80. If we get a request is timed out, whatnot, do not use this one. And we're going to go ahead and alert the SOC analyst saying, hey, this is down, the DevOps engineer. Go ahead and get this back up. So this is all done automatically on the back end for us. So health checks is perfectly cool. And I'm going to click on next. All right, available instances. Look at this. It's got my public web server, or I guess my naming conventions aren't too good, but we got this. Okay, so I'm going to select both these guys, and we are going to include as pending below. So we're going to review the targets. That looks great to me. I'm going to create this target group. And it's saying to unused. So it gives a little bit to kind of get this up to speed right now. So while this is actually kind of doing its thing, we could, let's see, what can we do? Let's go ahead and create our load balancer. So now we have our targets A, load balancer, put it over there. We just need to create that load balancer so it'll switch between the two. So I'm going to go back over here to the side. We're going to click on load balancers. I don't have any. Oh, what was me? Let's go ahead and create one. So there's a network load balancer. This will actually go on the level 4. We have a gateway load balancer. We want an application load balancer. We want our load balancing to happen on layer 7, because when we have WAFs, if it's on layer 7, we can inspect the packets and we can set up rules that will go ahead and say, hey, you're not slick. You're not getting by me. Application load balancer versus network, they have different purposes. However, you can get more fine-tuned when you are on layer 7 right here. So load balancer name, Matt's. Must not begin with a hyphen and only including a hyphen. Okay, Matt's amazing load balancer, LB. This is going to be internet facing. So we want the general internet to be able to access this. And we're doing this via IPv4, okay? Now we need to set up the network over here. We need to basically say, hey, this load balancer is going to live within this subnet within this VPC right here, okay? So we're going to select that. We're going to say Matt's amazing VPC. Mapping. So this is where the high availability comes from. We want to be in West 1A and West 1B. That's where both of our subnets are. I'm sorry, our EC2 instances are. So we want to be in both those. You cannot do this with just one. You can get an error if you try to run this because we need to be in multiple availability zones. What's the point of having the load balancer if it's only going to be on your one availability zone? Doesn't really make much sense. Security groups, I want the security group to be the same one. Just do the SSH, do the port 80. Usually what this would just be a port 80, because this is what's going to be actually facing the internet on our public site. So basically you would only say, I want the general internet to access port 80, and that's it. We would close off everything else before the load balancer would even forward this request over to the servers right here. However, for our intents and purposes, I'll just do Matt security group. Remember, this is port 80 and 22 that are open. That's fine for what we're doing right here. So this is what we need to focus on here. Let's see if I can make this a little bit bigger. So listeners and routing. So we have port 80. We need to have a default action, and we need to select that target group. Hey, when anything comes to our load balancer on port 80, forward it to this target group, which is our 2 EC2 instances. Okay. All right, listener tags, we don't need to go ahead and we already pretty much did that. So we are going to be doing this, but we're just not going to be doing this right now. I like to test everything kind of layer by layer before we add on top of this. So we're pretty much Mass security group, port 80 is cool. It's internet facing, it belongs to this VPC. It's going to be in this availability zone, and we are going to be listening for port 8080, and that's going to direct all the traffic to our targets group right over here. Go ahead and create this load balancer. So this sometimes takes between 2 and 3 minutes to go ahead and provision. So while this is actually provisioning, I'll open this up to questions. And folks, I know we are running a little bit over here. I was hoping that this demonstration would not take long. We are going to be doing the web application firewall demonstration after this and looking at logs to kind of get into the meat of this. This is just how you would set up a lab environment for testing out and applying some of these web application firewall rules. So yeah, I'll open this up. Any questions, comments, and concerns? Wesley says, can you host virtual machines on these servers? And if so, how would you do this? Excellent question, Wesley. If you actually think about it, our EC2 instances That's exactly what these things are. These are virtual machines. Literally, I spun up a machine. I picked out like the Ubuntu. I picked out the Windows. I can pick out the operating system. I can pick out the hardware, and it launches right here. And I have complete access to that computer. So these are virtual machines. You absolutely can spin up virtual machines on the cloud. That was one thing when at my previous position, when there was a whole thing about the M1 chip, and we couldn't admit a lot of students because it wasn't compatible with our Oracle VirtualBox. One thing I suggested was, hey, let's just spin up some instances on AWS and they can go ahead and do it that way. However, that would have been a big cost. So you absolutely can do that. Absolutely. Great question. All right. Thank you so much, Renee. Appreciate it. Appreciate you guys joining. All right, folks, so let's see. We are our load balancer is up. So would you see that we have our amazing load balancer? This is the address. You guys can actually go here too. And if we go here to AWS, this is Matt's amazing or awesome web page. Let's refresh a few times. All right, so we are getting 1, we are getting 2. The load balancer is saying, hey, which one is overburdened and sending direct traffic that way. Our load balancer is literally getting our request from the internet and deciding, hey, do I send it over to here or do I send it over to here? Cool. Now we have our load balancer. We have our EC2 servers that should be private. So the only way that they can access it is this load balancer. That is a pretty hefty responsibility that this load balancer has. So we should actually implement a web application firewall so we can inspect packets. And we can literally say, hey, none shall pass. We can set up alerts saying, hey, if somebody like Jackson or Bacola, they tried to do a cross-site scripting attack on us, that's going to alert the SOC analyst right there so we can go ahead and do that. We need a web application firewall just to kind of get some metrics on this load balancer on what kind of traffic that we have right now. So let's go ahead and do just that. So we have our, so this is just all the traffic coming through this load balancer. I'll throw this in the chat. Feel free to, feel free if you want to see Matt's amazing web page 1 or 2. You want to play around with it, go ahead. That's available right there. What's up, Jackson? Is there a question? Yeah, you can absolutely configure affinity or round robin. We could basically, I believe that was, we taught that in the intermediate, I think, like that. So let's say if we were over here, I could pretty much say, hey, load balancer, let's go ahead and use this one. And if more opens up, go ahead and automatically expand. Or, hey, I have 10 different servers. Hit this one, then hit that one, then hit this one, then hit that one. Load balancers do have artificial intelligence. So it thinks that it knows the best, but as we all know, AI is not perfect. As of right now. So let's go over here to our web application firewall. So I'm going to say WAF and Shield. Shield is DDoS protection. It comes automatically. However, it comes automatically because AWS, it's huge. Like they get, I want to say, over 100,000 DDoS attacks a day. And it's nuts. But what we want to do is we want to have something on top of this just to kind of fine tune, because we want to be in charge of this. I don't want to just say, hey, AWS said it, forget it. I don't want to do that. So I'm kind of, I'm very, very anal retentive when it comes down to the security, as you absolutely should be on this. So we're going to say create our web ACL. So let's go ahead and click on create web ACL. So real quick, I don't want to take us too into the night because I know you folks have places to be, but there's Amazon CloudFront distributions and there's regional resources. For our intents and purposes, we are going to be using application load balancers. So we're going to be using regional resources. Amazon CloudFront distribution is basically a content delivery network, a CDN. It basically, let's say if Richard, he was feeling spry one morning, so he wanted to go ahead and set up servers warehouses all around the world. And then if we wanted to put our servers, not just in these 2 subnets, we wanted to put them on every single one. So no matter anywhere in the world, if anybody's accessing it, they're going to get a very fast response. That's what CloudFront distribution is, and it's different from what we've been actually doing with regional. CloudFront is worldwide. Regional is whatever we discussed in our availability zones here. So we can do it in different regions. Mine is going to be in US West California, so it's going to reload our WAF right here. In California, I'm going to say for this WebACL, we are going to we want to limit the DDoS. So I'm going to say rate limits. I'm not going to do a cute little map span. So this is exactly, we want to name our rules to be descriptive as possible. Additional DDoS prevention. So CloudWatch metric name. CloudWatch is AWS's name for, hey, this is grand central of everything that's going down in your VPC. So anything that's, let's say if somebody does trip up over 100 requests in 5 minutes, there will be an entry into CloudWatch, and it will be under this rate limit right here. Amazon resources. We need this. We need to actually have our load balancer. So Maps Amazing Load Balancer. Cool. Let's go ahead and add this thing. I'm going to select that. We're going to click on next. All right. So there are rules and rule groups. For our intents and purposes, we are going to be looking at both of these today. And it's going to be web capacity units, web ACL capacity units. We will get into that when we get here. But we want some rules. We want especially our ad managed rule groups. These are the ones that's kind of like a marketplace, so to say. It's everything that AWS has, OWASP have. There are these rules that have been made, and you can go ahead and use them. Or you can go ahead and add your own rule and rule groups. I'm going to say add my own rule and rule groups, and we are going to do a rule builder. We're going to build this thing up from scratch. So the rule is going to be no excessive requests. We could do a regular rule, and the regular rule follows the same logic that you guys have seen. It's like, okay, matches this statement. The statement could be, okay, all headers have to be in scope. All headers have to include specific thing. We're not going to be doing this right here. So we're going to be doing a rate-based rule. So this is just basically going to be rate limiting. So the maximum number of requests to allow during a specified time window that satisfies your criteria. I'm going to say anybody tries to request my site over 100 times in, let's say, 10 minutes. I'm not trying to pay for that. So over 100 times, that is going to be a little bit too rich for my blood. So I'm going to have that right there. We're going to say source IP address. That's going to originate from a specific source, from you, Richard, Courtney, Jackson, myself, coming from our computer. We have IP addresses and headers. So use only a client address in the HTTP header. You want to be careful with this because headers. So this is just like what Richard was showing us the anatomy of a packet. Let's say I get Jackson's IP address. I get Bucola's IP address. I can alter my header to say that the return header is going to be Jackson's, Bucola's. So this is not substantial. This is actually coming straight from the source. So you want to always do source IP address. IP address and headers, there are specific use cases, but I've never really seen one. Now what we can do, okay, over 100 in 10 minutes, we can just go ahead and block them. We can count them. Hey, how many people went ahead and did this? We could throw a CAPTCHA at them, or we could do a little bit of a challenge. I'm just going to go ahead and say block. If you do it over 100 times to me in 10 minutes, I'm just going to go ahead and block it. So we're going to say add the rule. So we see now no excessive requests. We're going to go ahead and block that if anything matches that, and this is going to be to capacity. Capacity means web ACL capacity units, WCUs. So there is additional logic. So whenever, let's say, Bucola, Nathan comes over and punches in our load balancer site, okay? In addition to the load balancer, sending it over to our EC2 instance, it needs to compute. It needs computing power. So we have, so for doing the rate limiting, that's 2 out of what we have is 5,000 WCU. So it's not that much, and it actually executes these rules according to the capacity and the order that we're in. We do cross-site scripting after this. We'll be looking at it kind of goes down. You don't want to do this because the more computing power, the more expensive it is going to be. So let's say if Jackson comes through, he's not trying to DDoS me. The default web ACL, it doesn't match any of these rules. Nobody's trying to DDoS me right now, so I want to allow them to access this. Or I can just do a deny null, an implicit deny, saying, oh, no, you know, if they're not doing any of this stuff, go ahead and block it. I'm going to allow this just because this allows traffic to go through. We're going to click on next. So rule priority, if we had more than one rule, they would appear here. So it's like, hey, which one are we going to hit first? All right, since we don't have it, we're just going to go ahead and chill. Amazon CloudWatch metrics. So no excessive requests is going to be, allows you to monitor web requests, web ACLs and rules, et cetera, et cetera. And enable sampled requests means AWS is going to test these on their end. And if there is anything else, it's going to go ahead and show up in the log. So you want to go ahead and enable sample requests. It is very, very helpful for testing right here. So we're going to review, and we're just going to go ahead and create this guy. So now that this is, I mean, shoot, maybe I should have put it on a CAPTCHA so we could have refreshed this thing 100 times, but I guess we have better things to do with our time than that. And we would have seen the CAPTCHA here. But as of right now, web ACLs, it takes maybe about 2 to 3 minutes to go ahead and create each one. So our enhanced DDoS protection is going to be active on this. So rate limit, advanced DDoS protection. We are sitting pretty. That is up and running right now. Rate limit. We are cool. Let's see. I'm going to go over here. I'm going to just refresh a few times. All right, so let's go ahead and see. This is not, it's basically going to say, hey, how many requests were allowed? How many requests were blocked? What are the total? How many people did we throw the CAPTCHA to, the challenge? And it can take a little bit to populate. So while this goes ahead and populates all the traffic that I just gave it, let's go ahead and look at cross-site scripting. So who here remembers what cross-site scripting is? Go ahead and if you want to share, go ahead and unmute yourself or throw it in the chat here. Jackson, some things never change with the quickness on all the correct answers. Jackson, gold star to you, my friend. So cross-site scripting is embedding a script in a web page. To show you, since we're running a little bit low on time, I'm just going to do a quick refresher on this. So cross-site scripting. I have a website that I programmed here, and basically, if you guys remember Beef, if you have a JavaScript file, what you can do is you can embed this on somebody else's page, and that will actually give you the control to everybody, to the person's computer, and they would never even know it. So the way that we actually test for cross-site scripting is we want to see if the script tag can actually return back an alert. If it can, we can go ahead and embed that script. And just to kind of personify what I'm saying, this is just Cybersecurity Photo Store. I made a dummy account, matt@matt.com. Let's go ahead and log in. Here's a picture that I took in San Francisco. And if I did an inspect element right here, it's not inspect element. If I did a view source right here, see if we can make this bigger. This is one thing for cross-site scripting. It's something that you never want to do. If you ever see scripts, so this is actually JavaScript running around here. You ever see document write? That's not a good thing, because document write means that you can directly edit the page on what the server is actually spitting out to us. However, I see that these two sizes are inside the URL. These are queries, okay? So we have pic, we have the ID is going to be equal to 2. So that's whatever the picture ID is. The size is equal to, let's see, 8 by 10. If I wanted to link my own malicious JavaScript file, I would say, I would do something over here, like we would do a script tag. And we would say alert. And we would close that tag, and we would close out the script tag. Since this JavaScript actually worked on here, and this alert from hello is coming from my server, that tells me right here that this server is vulnerable to cross-site scripting. I can go ahead, if I can basically put a script inside of here. I can have my URL to my malicious JavaScript, my Beef browser exploitative framework. If you guys do not know what that is, definitely do a Google search or watch a YouTube video on it, because it is very, very scary. You don't have to download anything. You just go to a website and the attacker has control. If we had more time here, I could demonstrate it out, but for the sake of brevity, I want to go ahead and just kind of get through this. But that's how you test to see if anything is vulnerable to cross-site scripting. If you can get an alert over here, that means that JavaScript is absolutely live, and you can pretty much have your way with that specific website right here. So with that being said, I don't want any cross-site scripting coming over here. I don't want anybody trying to get on this. What if I actually did upload this, but I don't know how to secure it on my back end? I want my operations to go ahead and secure that for me. Well, WAF definitely has you covered here. So I'm gonna come back over here. And what we are going to do here is I'm gonna click back on web ACLs and we're gonna create the web ACL, okay? Made the same thing, we're in Northern California. Let's say this is going to be OWASP. So the open web source project over here, OWASP, yeah, OWASP top 10. And we are going to put this on our load balancer, okay? So select that, we're gonna say next, and we don't have any more rules. So let's go ahead and add our rules. And this time we're gonna go into our managed rule group. So these are all the ones that AWS has for you. And they're not free, but they are very, very helpful. So there's account creation, fraud prevention. You do not want your AWS account to get taken over. That's account takeover prevention. That they have some mitigation. So if I want to do this ad, it's $10 per month to actually go ahead and do this. I can click on edit and we can say inspect all the web requests and we can just basically configure our own rules. So Cognito is a login and registration service via AWS. Password traversal, username traversal. If anybody's trying to use that new RockU 2024 that just got released, this could go ahead and be of service for you. So you can go ahead, oops, should click that, let's say OWASP. And OWASP. Reattach to our load balancer. Cool. All right. So if we're in the managed rule groups, one thing this is a bargain. So we have bot control. So we have good bots, we have bad bots. Let's say if Richard starts up a website and he wants Google to do some SEO, do some search engine optimization, bump them up there. There are good bots. We don't want to discourage good bots from crawling our site. Bad bots, we absolutely do. So you can go ahead into bot control. And we have this all there. There's free rule groups. There's anonymous. There's core rule sets. There's all this other good stuff. SQL database, SQL injection, Windows, WordPress, all this other good stuff. What I'm going to be doing here is enabling our core rule set. So let's click on edit and let's take a look at exactly what's going on right here. So we want to inspect all of our web requests. And we can do some overriding actions. So let's say that there's no user agent. So in the packet, a user agent says, hey, I'm on Firefox. Hey, I'm on Safari. If there's no user agent, chances are that's going to be a bad bot. So you can say, hey, no, I want this just to block. I don't want anything that has to go. The bad bots, anything like that. Server-side request forgery, all this other good stuff. So we have cross-site scripting. What we did here was a query argument. Since there is a query, you see this question mark ID equals, that means we are querying something inside the web, inside the URL. So I want to just see if this is actually working. So let's go back over here. The query argument, I want to do a CAPTCHA. So if there is anything coming against our load balancer, that's going to do CAPTCHA. So I'm going to go ahead and save this rule. I'm going to add the rules. And look at this now. We have 700 out of our 5,000 web capacity units. So we're still operating pretty much good. Anything else that doesn't match it, we want to go ahead and allow it. Rules, we are going to go ahead and do that. Enable sample requests, absolutely. And we're going to create this web ACL. Now that this is, now that we have protection against this, let's go ahead and try one of our cross-site scripting attacks that we have put in the URL. And let's see what happens exactly when WAF will it actually catch it and whatnot. Jackson says, can you just close the browser to stop the scripting? Yes, Jackson, absolutely. So let's say if you have cross-site scripting and you're on here and somebody has a hook into you. If you close it, they do not have that anymore. However, there are ways to do persistence. If they can make it like it looks like Firefox says, hey, go ahead and install this plugin. You install it and it's pretty much, they have persistence at that point. Or if you're anything like me and you keep a million tabs open and you just forget about them, that is what cross-site scripting vulnerabilities are very, very dangerous, because if you have a tab open and you forget about it, it's pretty much open season. All right, so we have OWASP and we have rate limit as of right now. So we are pretty much sitting pretty. Let's go over here to Mass Amazing. So I'm gonna do a let's see, what am I gonna do here? Let's do a I don't know, let's do a / we're gonna say Q for query, question mark equals. So it's going to say we're going to be doing a query here. And we're going to say script. Oops. If I can spell script. Alert. Hello. All right. Uh-oh. Look what happened. We overrode that from the web firewall, and we have a captcha right here. Let's confirm you are human. All right, let's see what's up. The hats. All right, et cetera, blah, blah, blah. Web firewall caught this and saw that I was trying to do something that was akin to a cross-site script. And oh man, did it catch me. It would have outright blocked me, and it would just said, hey, this is completely blocked to you. However, it gave me the captcha because in those rules, I said, hey, go ahead and throw a captcha at the person if this rule is triggered. So as of right now, we are pretty much good. We are sitting pretty here. Let's refresh this to see if we have the logs updated just now. Logs have not updated right now. So traffic overview is going to be where you want to actually see all the results, just kind of going through the logs. We have associated AWS resources. So we have, okay, it's attached to our line, our load balancer, excuse me. Login metrics over here. So it is the sample request. Everything is cool. We have not yet actually enabled logging for CloudWatch. So CloudWatch is going to be in that specific rule set, but for WAF as a whole, you would want to go ahead and enable that right here. Sample request as just the same over here too. It's going to basically say, okay, look at this sample request for our rule set. We saw this hello. That's exactly what I put on over in here. In our sample request, that is already, here is my IP address. If you guys want to hack me, feel free. But cross-site scripting query arguments was a captcha. Look, today at 18 o'clock, this got it. So I would see this. I could actually use another AWS like simple messaging, alert, hey, this was done. We can go ahead and take, risk mitigation tactics to go ahead and fix this up. So let's see if the traffic overview refreshed. If not, yep, it did. So there was one total, there was one captcha that was given, it was 0 blocked, 0 allowed, and 0 for that challenge. And would have the spike. One time, this little dial on here, this is what time that incident happened, and we are pretty much off to the races here. Well, all right, folks, if you guys made it this far, I appreciate you guys hanging in here with us. I had a blast tonight. That is how you can build some infrastructure with 2 servers, an application load balancer, 2 subnets, a virtual private cloud, and a AWS web application firewall configured to your liking. Does anybody have any questions, comments, or concerns here? Thank you, Jesus. Thank you, Sergio. I really do appreciate that. Thank you, Abdur. All right, folks. Thank you so much, Courtney. I'm glad you enjoyed you guys' self. Thanks, Nathan. Appreciate you, Wesley. So, folks, Richard, do you have a timetable for the follow-up survey? You're muted.
Are you gonna create a landing page for that? How do you want to do that? Or we just want to send an email?
Yeah, I'll create a form and then we can send an email for now.
Okay, but I'll be sending out the link shortly
Perfect.
for the video. As soon as you get me the landing page, I can send out an email.
100%. Awesome. Well, folks, thank you guys again. It was wonderful seeing all you guys. You guys have my email address, Matt.Schiller or mschiller@HackArmory. Any questions at all? My door is always open to you folks. LinkedIn, all that other good stuff.
Have a good night.
Carter Jackson, yep. You too, folks. Thank you.